Good morning. Last class we discussed the introduction part of corrosion. Today we are going to discuss about the types of corrosion. Based on the environment, corrosion is classified into two categories. One is dry corrosion or chemical corrosion. Second one is wet corrosion or electrochemical corrosion. First one is dry or chemical corrosion. Dry corrosion is due to the attack of metal surfaces by the atmospheric gases such as oxygen, hydrogen sulfide, sulfur dioxide, nitrogen, etc. There are three main types of dry corrosion. First one is oxidation corrosion or corrosion by oxygen. Second one is corrosion by hydrogen. Third one is liquid metal corrosion. First one is oxidation corrosion or corrosion by oxygen. Oxidation corrosion is brought about by the direct attack of oxygen at low or high temperatures on metal surface in the absence of moisture. Alkali metals, that means lithium, sodium, potassium, and alkaline earth metals, magnesium, calcium, tin, etc., are rapidly oxidized at low temperature. At high temperature, almost all the metals except silver, gold, platinum are oxidized. Then mechanism of dry corrosion. Oxidation occurs first at the surface of the metal, resulting in the formation of metal ions, which occurs at the metal. That means metal undergoes oxidation process. Oxidation means loss of electrons. So two electrons are lost at the reaction of oxidation. Secondly, oxygen changes to ionic form due to the transfer of electron from metal which occurs at the oxide flame. So, half O2 plus 2 electrons gives O2 minus. So, oxide ions react with the metal ions to form metal oxide flame. So, M2 plus O2 minus gives MO, that means metal oxide flame. Once the metal surface is converted to a mono layer of metal oxide for further corrosion, that means oxidation to occur. The metal ion diffuses outward through the metal oxide barrier. Thus the growth of oxide film commences perpendicular to the metal surface. This is the diagram for metal oxide formation. So metal is converted into metal 2 plus ions plus 2 electrons. The 2 electrons flows into the atmosphere to form oxide ions. So metal ions plus oxide ions combine to form metal oxide film. Nature of the oxide film. The nature of the oxide film formed on the metal surface plays an important role in oxidation corrosion. First one is stable oxide layer. Second one is unstable oxide layer. Third one is volatile oxide layer. Fourth one is protective, non-protective oxide layer. First one is stable oxide layer. A stable oxide layer is a fine grained in structure and gets adsorbed tightly to the metal surface. Such a layer is penetrated in nature and stops further oxygen attack through diffusion. Such a film behaves as a protective coating and no further corrosion can develop. Examples: oxides of aluminium, tin, lead, copper are stable oxides layer. Unstable oxide layer. Unstable oxide layer is mainly produced on the surface of noble metals which decomposes back into the metal and oxygen. So metal oxide layer is again converted into metal plus oxygen. Examples: oxides of platinum, silver or unstable oxides layer. Then third one is volatile oxide layer. The oxide layer volatilizes as soon as it is formed, leaving the metal surface for further corrosion. Example: molybdenum oxide is volatile. Last one is protective non-protective oxide film, that means Pilling-Bedworth rule. According to Pilling-Bedworth rule, if the volume of the oxide layer formed is less than the volume of the metal, the oxide layer is porous and non-protective. Example: volume of oxides of alkali and alkaline earth metals such as sodium, magnesium, calcium is less than the volume of the metal consumed. Next one is, on the other hand, if the volume of the oxide layer formed is greater than the volume of the metal, the oxide layer is non-porous and protective. Example, volume of oxides of heavy metals such as tin, lead is greater than the volume of metal. So, Pilling-Budworth ratio is volume of the metal oxide divided by volume of the metal consumed. Thank you.